Okay, so what we're interested in is to identify what are the semantic spaces that are part of BiomarkerKB, the database, and put those into the bioregistry. And so in general, when we make new semantic spaces as part of databases or ontologies, we can register them in the bioregistry such that anybody can find out what is the resource, how should they reference entities within that resource, within their semantic web applications, within their database cross-references on ontologies, and also how can they take references that are either in the forms of like queries, these compact URIs that have a prefix that corresponds to the name of the semantic space, and then the identifier within the semantic space. The bioregistry also helps to resolve those two URLs in a way such that you can have a generic resource and you can take the query and format it with the bioregistry's web address, and then that takes care of knowing what is the backend that it should redirect to. So where we are is we actually have two different semantic spaces within BiomarkerKB. There is the canonical biomarkers, which describe, I just read this off, which describe sort of a measurement of a change to some entity, like the increase in IL-6 level. And these canonical biomarkers, they get identifiers that look kind of like this. They have some letters and then some numbers after them. In fact, it's always the case that it starts with an AN and then there's some numbers after that. So inside this bioregistry record, we can capture that pattern. So also people can validate their identifiers to make sure if they get content from somewhere else that they all at least follow the rules that are predetermined. The second part of BiomarkerKB is this more specific part where you sort of compose the canonical biomarker with a disease, and then you make the measurement, a disease or condition-specific measurement of this entity. And so like using the same example from AN6278, that like specific condition or disease specific biomarker would like have the same beginning part and then a dash and then a number at the end, and that number corresponds to the disease. And that's sort of like internal with respect to which disease that means. A different way to do this is to use other ontological techniques for post-composition, where you have like the disease ontology identifier for whatever the disease is, and then you have some combination of the canonical biomarker and that disease ontology. However, like inside your resource, you've chosen to give identifiers this way, and that's totally fine. However, I just want to stress that it's really valuable to have these considered as two different semantic spaces, and therefore in the bioregistry, each of them gets their own prefix. And that's useful for people who want to like look up the entities and maybe do some reasoning or queries over knowledge graphs or triple stores or places that contain this sort of information in sort of a generic schema where they might want to look for certain things. Having that prefix to tag it gives a lot of contextual information to people who want to use it before they use it. Okay, so I spoke very fast, but that's the idea. That's where we started. The big question that I have is, does this all sound okay to you to make this kind of two different semantic space difference? So another resource which does things this way is UniProt, where UniProt has an identifier for each protein. And then they have a more specific contextual identifier that has information about which isoform of the protein it is. So I would say that BiomarkerKB is in the same situation as UniProt in the way that it has this kind of extension, a canonical namespace, and then like an extension namespace. So
Yeah.
everything makes sense until then. Have some questions.
No, everything makes sense. Just to give you where we are in even understanding how to organize, as you can understand, this is very new. This is not as simple as being a protein database, right? So it's very new. There's no book chapters or even papers who have really gone deep into understanding how biomarkers need to be organized. So it's research. There are pros and cons to it. It's really exciting. And every time we do something, we also realize, so we are in our second year right now in the project. So this will is in our 4-year total cycle of our funding, right? So there has been a lot of churn in the first 2 years, and things are stable, but please, UniProt is what, 6 decades now old? So we are nowhere there, right? So think about, we are in the stages of PIR, PSD, where Margaret Dayhoff kind of was figuring out how the accession space should be and all of that. But we are much better because we have groups like Uniprot and many other resources where we can say, oh, this one works, this one doesn't work. So your idea about the DOID is well taken. And there is a possibility that if we get renewed after our 4 years, we will most probably, we are doing things so that we can automatically or close to automatic make changes based on feedback we are collecting within the first 4 years, right? So it will be very trivial for us to do the isoform concept that you're talking about, Uniprot, change to DOID or maybe some other type of ID. We do not know. It's DO is one of the several possible scenarios where these conditions map. It's like 99, 98%. There are 2% maybe which may not map to DO immediately. We may get new terms in DO, or we can map to something else out there. So these are well taken. Yeah.
Yeah, and that was not a criticism of doing it this way. There's definitely benefits. And so when you do decide to build a knowledge graph around this, you'll connect these biomarker terms that have the dashes in it to some kind of controlled vocabulary, whether it's DOID or a different one or some combination of the best ones from different places. And
so
then people
we already have a knowledge graph
yeah.
on BiomarkerKB. It's an active area of research of my PhD student, Daniel. But we also have knowledge graph, which actually is in review through another collaboration. So you're absolutely right. This is fantastic. We really, really, want to, please continue. And I think there are great ways we can also see how the KG, but the KG is not using what you are showing right now, right? That's what, would love to hear how you can see that can help. And maybe have a follow-up call with Daniel later on.
Okay, so like the next steps, when we build namespaces or semantic spaces, which is the term that I'm using, right? We have some set of identifiers, they have labels, they have contextual information that we're curating as biocurators. We have to decide a couple things. Like, first of all, how do people get that information? And most people would love to have a website. And so one of the lines in the bioregistry is this URI format, which basically says if you've got an identifier, you can build a URL from it by placing the identifier where this placeholder $1 goes. And it's already, I think you've already made a really good choice, whether knowingly or not, to have a different kind of URL that will give you a web page for the disease-specific ones and a different kind of URL that will give you information for the canonical biomarkers. And of course, these web pages will be linked to each other, so you can hop back and forth and find out more information. But this is super powerful because in the semantic web world, everything eventually becomes URIs. And so making good choices about how the URIs are constructed makes it easier for people to use your data later. And this is great. And so we can reflect that in the bioregistry. And then what we can do later is actually give people the bioregistry as a tool for them doing research data management, where you say, hey, if you build a data set and you want to use our identifiers to talk about your biomarkers, this is the right way to write them down such that your data can be easily integrated with ours and others. So we're already like 99% of the way there because everything kind of fits together nicely. But that's what we want to be able to tell your collaborators and people who are going to be using your data, that the bioregistry can be a place where they find out, here's what identifiers should look like, here's the standards. In addition, it's also the case that you can sort of have ad hoc descriptions of these things on the website as well, but we put it in the bioregistry so it's machine actionable. And so the configuration here, it's not so complicated, but because it's structured, it allows people who are working with the Python programming language, with other programming languages that interact with the bioregistry, they can use it for all these purposes that I mentioned before, for data integration, for standardization, for construction of URLs and making websites. So all that being said, the big question that I have is what to call the semantic spaces. And this is the other big discussion and decision to make, because within semantic web documents like that are in ontologies or have triple stores, Sparkle documents, turtle files, typically you define what the prefixes are. And it's also really valuable for the resource itself, or the people maintaining the resource to say, hey, this is how we want you to choose the prefix for when you reference our things. And that's a question that we're going to discuss together right now. I can tell